Hi everyone, today we are going to demonstrate the balancing act as the demonstration's idea for the concept of center tendency.
Yes, he is right. We are going to reuse these boxes as the balance beam and these books as the weightage. Let's start.
First, we need to find the balance point between the boxes without any weightage. The balance point where the beam is level actually indicates our mean point in the center tendency. Informally, we understand the mean point as the point that indicates the weight distributions is balanced in our balance beam. Let's mark this as our initial balance point without the additions of weightage.
Now we will add one book to each side of the balance beam and mark the new balance point. It is clear that the balance point is different from the initial balance point. This situation can be related to the concept of central tendency, where the mean point changes as we have added new data into the set.
Now, let's try with the additions of one more book. The conditions stay the same as the first observations, where we need to find a new balance point that indicate we need a point to make the weight distributions is balanced in the beam.
Next, we will be demonstrating the idea of median. First, we arrange the books from the smaller to largest on the balance beam and try to make the balance beam stable and balanced. Then we take the middle book. The middle book actually indicates the median in the central tendency. In the balance beam, the middle book is the book that makes the balance beam stable and the balance beam will out of balance when the middle book is removed.
Informally, the median is the middle point from the set of data that we have. The requirement is that the data need to be arranged in ascending order. In our illustrations, we arrange the book from the least to the most pages, and the middle book will indicate the median.
Next, we need to balance the balance beam without changing the location of the balance point. First, we put a calculator book onto the one end of the beam. Then we add books one by one on the opposite side and identify the number of books needed to make the balance beam balanced.
When the beam is balanced, we identify the number of books on each side of the beam. The number of books that is greater is our mode in the concept of center tendency. So in these conditions, we have the two mathematical books from Form 3, which is our mode.
Informally, the most frequent data is the mode in the data analysis, where it appears more frequent in the set of data. That's all about the concept in central tendency.
Thank you for your attention.
In this part, we will demonstrate the concept of measure of central tendency through a simple story. A boy who called Wei Jie faced difficulties in solving his mathematics homework. He later falls asleep and dreams of 3 little animals helping him to solve the problems.
Hey you, wake up!
Who are you?
We are Triple M.
We are here to help you.
What can you help?
I am Ming Ting.
To get the mean, you have to get a set of numbers and add them up. After that, you divide the sum of numbers by how many they are. That is the mean, or sometimes we call average. Basically, you add and divide to get the mean.
I think I understand it.
It's my turn now. I am median rabbit, the one in the middle.
To find the median, you have to arrange the numbers in ascending or descending order. Then, whatever in the middle is the median.
What if I have even amount of number?
You just add the two numbers in the middle and divide by 2. The answer you get is the median.
Oh, I see.
Hey, don't forget about me. I am mod sheet. What I do is to find the most common and popular number like me.
First, I make up my list from least to greatest. Then, I see if there is any numbers that are the same. The most numbers that are the same are the mod.
Just to let you know, mean, median, and mode are always used to measure the central tendency.
Basically, they are the values that indicates where the data points tend to concentrate.
Items which are grouped around the mean have strong central tendency. Conversely, items that aren't grouped with any significance have weak central tendency, and thus they are less reliable.
Oh God, thank you so much for your help. I think I can complete my homework now.
But first, you have to wake up.
Huh? What?
Hey guys, I believe there are difficulties in understanding the concept of measure of dispersion. Today, we are going to use an interesting way to illustrate the idea of dispersion.
So before that, we need to prepare the 4 balloons, and the marker pen, and the measuring tape.
After preparing that, we first need to measure the circumference of the balloon. We pick the greatest circumference part of the balloon. Then we surround it with measuring tape.
So we then record the measurement on the balloon. So after we record, we will show you the measurement. We will explain the concept of dispersion based on the data we obtain. So we can find the smallest and the greatest measurement from the set of data. For example, from this set of data, the smallest is 49.5. However, the biggest is 71.5. So by taking the difference between the smallest and the greatest value, we can get the range, which is 22 centimeters.
We have another two concepts in the dispersion, which is the variance and the standard deviation. There are a series of calculations to find the variance and standard deviation that indicate the spreading of our data. Informally, we can observe the spreading of our data, but we need further formulas and steps of calculation in advance to know the value. That's all from our session. Thanks.
Hi, I am Ming Ting. Together with me are Wei Jie and Ming Ting. In my part, I will be introducing the general concept of dispersion. But before that, I would like to highlight why the measure of dispersion is important by using an example. Let's say you are working for a pharmaceutical company and you need to decide between 2 different medications for depression. Thus, you measure how much improvement happened when people took one over the other. And these are the graph you got. So let's say the highest score means you know more improvement and lowest score means little to no improvement. Well, let's kind of compare. The means in this case are the same. In both cases, people improve by about 10-ish points. But the variability is very different. On the top, some people benefit very greatly, whereas others really didn't benefit at all. But at the bottom, everyone benefits a good amount. So in this case, I will choose medication at the bottom because it is more consistent. So this is an example of why knowing the variability might help us to make some real-life decisions. In general, dispersion is the amount of variation within a data set. They describe how scores in a given data set differ from one another, and they capture things like how spread out or how clustered together the points. So, we are going to discuss 4 commonly used measures to indicate the dispersion, which are range, interquartile range, standard deviation, and variance.
Hi everyone, I am Wei Jie. Now I will continue to explain about the range.
It is the simplest measure of variability of dispersions on how spread out points are. The calculation for range can be done by the subtractions of maximum and the minimum value. In other words, it is the difference between the value of highest and the lowest observations. But what is the limitation of range? Even though it is simple and pretty effective, we might miss a little bit of data and information. Here is the data set. We have one person who scored 30, one person who scored 40, and so on. The range here is 120. But let's look at the second data set in this case. The range is still 120 because our highest and the lowest value are the same. So, if we just look at the range, it might be misleading because you are not sure if the data looks like on the left or on the right. And this is where standard deviation and variance come into play. There is an element in a range which is interquartile range. It defines the spread of the middle half of our distribution. Quartile segment order from low to high into 4 equal parts, which is the first, second, and third quartile.
The interquartile range is found by subtracting the Q1 value from the Q3 value. Q1 is the value below which 25% of the distribution lies, while Q3 is the value below which 75% of the distribution lies. You can think of Q1 as the median of first half and the Q3 as the median of the second half of the distribution.
Hi everyone, I'm Ming Ting. So now I will explain about standard deviation. Standard deviation is a measure that indicates how much data is scattered around the mean. It is the quadratic mean of the distance from the mean. If mean present, standard deviation decreased because the data concentrated in the middle. However, if mean absent, the data is more spread out. Hence, the standard deviation will increase. So, you can calculate the standard deviation by the following formula. Sigma is standard deviation. N is the number of people. Xi is the size of each person. And last but not least, X bar is the mean value of all persons. From this formula, we can know that standard deviation is the root of the sum of the square deviations divided by the number of values. From demonstration 2, we first need to calculate the mean. So how to calculate the mean? First, we take the circumference of all balloons, then divide by the number of balloons, which is 4. We will get the mean is equal to 59.4 centimeter. After calculating mean, so now we can proceed to calculate the standard deviation. First, we calculate the circumference of the first balloon minus the mean and square that. The circumference of the second balloon minus the mean and also square that, and so on until the last balloon. Then, we divide this number of balloons, which is 4, and square root them. So each balloon has some deviation from the mean, but on average, the balloon deviates 8.2798 cm from the mean, which is the standard deviation. After talking about standard deviation, now I would like to ask what is the difference between the variance and the standard deviation? The standard deviation is the average distance from the mean. However, the variance is the square average distance from the mean. So, we can simply take the data from the standard deviation and square it, so we will get the variance. Now, I would like to conclude about standard deviation and variance. For standard deviation, the root is taken. So, standard deviation is always in the same unit as the original data. From demonstration 2, our case is centimeter. So it is advisable to always use the standard deviation to describe data, as this makes interpretation easier. However, the variance is more difficult to interpret because the unit is the square of the original unit. In our case is centimeter square. That's all for our session. Thank you and have a nice day.
There are several common misconceptions students may encounter when they come through the idea of measure of central tendency and measure of dispersion. Here is how.
Teacher, is 20 the mode of the set of the data?
No, mod is the most occurring value in the set of data, not the highest value in the set of data. So in this example, 15 is the mod, not 20.
Nice.
Teacher, there is no median in this set of data because there is no middle value.
No. There is median in the data. The median is right over here. The median is the value that divides a data set in half. It does not necessarily have to be one of the values inside the set. If the number of observations is even, the median is the average of the two middle values, which is 13 and 15.
Oh my god!
Teacher, is the mean always the best measure for the center tendency?
No, while the mean is commonly used measure of central tendency, it may not always be the best choice. For example, if there are outliers in the data, the mean may be heavily influenced by them, and the median or mode may be more appropriate.
Yeah, boy. Later.
Now, let's talk about measure of dispersion. Do you guys have any question regarding measure of dispersion?
No! God, please, no! No!
Teacher, is it true that the range is the best of the measure of dispersion?
No. A range only considers the difference between the highest and the lowest value in a data set. It does not provide information about the spreads of the values in between.
How about standard deviation? Is standard deviation a good measure of dispersion?
Although the standard deviation is commonly used in measure of dispersion, it may not be the best choice. For example, in the data is not normally distributed, the standard deviation may be less informative.
Teacher, if the dispersion is more, does it mean that the data is not diverse?
While a small measure of dispersion, such as a small standard deviation, may include that the data is tightly clustered around the mean, it does not necessarily mean that the data is not diverse. It is possible for a data set to have a small measure of dispersion and still contain a whole wide range of the values.